Ever wondered how massive tech giants like Meta deal with the retirement of products or features without disrupting everything else? In this video, let me walk you through this fascinating process. These giant companies, they build and ship countless products, features, each comprising a web of different components. But what happens when a part of a product or an entire product is retired and its code and data need to vanish from the system? Enter SCARF, Systematic Code and Asset Removal Framework that Meta implements. It's not just about deleting lines of code, it's a meticulously crafted framework that ensures safe and efficient removal of obsolete components. Think about it. What if we remove something that's still in use? Chaos, right? So, SCARF helps engineers at Meta avoid that. So, they've got a three-part blog series that explains this process. Now, I have read the blogs that they have published about dead code removal, and I will be explaining a very simplified version of it. First, they generate a code dependency graph for each language, which is extracted from their compilers via Glean. This code dependency graph should be capable of handling multiple languages. So they mention that this code dependency graph is capable of handling Java, Objective C, JavaScript, and even server code written in Hack. Then they find unreachable nodes and subgraphs that can be deleted, which are discovered in runtime, because you need to perform dynamic or find out dynamic references rather than just do a static code analysis. Let me tell you why. Earlier, they found individual pieces of code with no inbound dependencies, but later they switched to this process of end to end scanning. Next, they also give us a very simple example for us to understand how this whole process works. Here we have a original code in Python where there is an if else check. Next, we have an optimized code which is just one line. Here they give us an example of how this optimization came to be. Here in the original code, you use an is instance check to determine whether the renderer belongs to photo renderer class. If it's a photo renderer instance, it calls renderer.renderPhoto. If it's not a photo renderer instance, it defaults to renderer.renderGeneric. The optimized code removes the is instance check. So, what is the reasoning behind this optimization? If there are no instances where photo renderer is instantiated and renderer is of this type, then the first branch of the if condition will never execute. Thus, so renderer never belongs to the photo renderer class. So the check is unnecessary. Consequently, the code can be simplified by directly calling the renderer.renderGeneric. Now, this is a very simple if else check. What about code removal at scale? Sometimes when you do things at scale, there are false positives are bound to happen. So these false positives are caught by engineers during code review, which is triaged, and then which is again used to improve how Scarf performs. So Scarf is a continuously learning tool that will take new sources and then figures out dynamic instances of code removal. So they also have a separate blog where they explain the process of what happens when incorrect code deletion happens. Each release is rolled out to 100% of production in a tiered fashion. So over a few hours so that they can stop it at any point if they find problems. So this is a very simplified, simplified explanation of what I've read on the blog, on the Meta blog about automating dead code cleanup.